Hey everyone, and welcome. Today, we're diving deep into the world of embedded communication. We're going to break down the ISOTP protocol and see exactly how it works inside the Zephyr RTOS to smash through one of the biggest limitations of the CAN bus.
So here's our game plan. First, we'll get a handle on the core problem, CAN's data limit. Then, we'll see how ISOTP comes to the rescue. We'll peek under the hood at the protocol's handshake, see how to actually use it with the Zephyr API, and then we'll wrap it all up with a quick cheat sheet so you don't forget the important stuff.
Okay, let's get right into it. To really understand why ISOTP is so cool, we first need to understand the fundamental problem it was designed to solve. I mean, why does this protocol even need to exist?
Well, it all boils down to this number, 8. Just 8 bytes. That is the absolute maximum amount of data you can cram into a single standard classical CAN frame. That's it. Now for super simple things like a temperature reading, that's probably fine. But for anything more complex, it's a huge bottleneck.
Now, I know what you might be thinking. What about CAN FD? Flexible data rate. And you're right, it's definitely an improvement. It bumps things up to 64 bytes per frame. But let's be honest, in today's world, 64 bytes is still practically nothing.
Yeah, this is a real problem, right? What if you need to send a firmware update over the air, or a big configuration file, or some detailed diagnostic logs? You just can't do it in one shot. And this is exactly where our solution comes into play. And that brings us to ISOTP. You can think of it as CAN's secret weapon for handling the big stuff. It's the official, standardized answer to this whole data limit headache.
So here's the crucial thing to understand. ISOTP doesn't replace CAN, not at all. It's a really clever layer that just runs right on top of it. It takes your big chunk of data, chops it up into these little CAN-friendly pieces, sends them over the bus, and then perfectly reassembles them on the other side.
And this is the result. With ISOTP, you're not thinking in terms of 8 or 64 bytes anymore. The theoretical limit gets blown wide open to 4 gigabytes for a single transfer. I mean, that's not just an upgrade, that's a complete game changer for what you can do on a CAN bus.
So how does this magic actually work? Let's take a look at the conversation, the back and forth protocol handshake that makes sure all these little pieces get sent and reassembled correctly without, losing data or crashing the receiver.
Honestly, this is the perfect way to think about it. You can't just attach a huge high-res photo to a single text, right? Your phone breaks it up into a bunch of smaller messages. Your friend's phone receives them one by one and stitches them back together. ISOTP is doing that exact same thing, just in a super structured and reliable way for our embedded devices.
The whole process is kind of like a 3-step dance. First, the sender kicks things off with a first frame. This is basically it saying, hey, listen up, I've got a big message coming your way and it's this many bytes in total. Then, the receiver replies with a flow control frame, which sets the ground rules. And only then does the sender start streaming all the data in what are called consecutive frames.
Now that flow control frame is absolutely critical. It's how the receiver stays in charge. It can say something like, okay, I'm ready, send me a block of 10 frames, that's the block size, and then wait at least 20 milliseconds between each of those frames so I can keep up, that's the separation time. This whole mechanism prevents the receiver from getting flooded and dropping data.
Okay, so the theory is great, but how do we actually use this in our code? Let's look at how the Zephyr RTOS makes this full process incredibly simple with its built-in API.
The beauty of the Zephyr API is that it boils that entire complex protocol dance down to just 3 main functions. You basically set up your listener, you send your data, and you receive the final package. Zephyr handles all the messy details in the background.
First up, on the device that's going to receive the data, you have to call ISOTP bind. Think of this like setting up a dedicated mailbox. You're telling the system, hey, be on the lookout for an ISOTP message coming to this specific CAN ID. When you see it, start collecting the pieces and put them in this buffer format.
Now, from the sender's side, it's even easier. You just call ISOTP sent. You literally just hand it your giant chunk of data and tell it how big it is. That's it. Zephyr's ISOTP layer takes over and does all the hard work. It creates the first frame, it listens for that flow control response, and it sends all the consecutive frames exactly as instructed.
And finally, we're back on the receiver. Once all those little PCs have arrived and been perfectly reassembled, you call ISOTP RECV. This function goes to that buffer we set up with bind and pulls out the complete message for you. It's what we call a blocking call, which just means your code will pause and wait right there until the entire message is ready.
Of course, in the real world, things don't always go perfectly. The API is really helpful here, giving you specific error codes to figure out what went wrong. You might get a timeout if the other device never responds, or an error because your CAN hardware is out of message filters, or even a buffer overflow if the receiver signals that it's full.
All right, that was a lot to cover. So let's quickly boil it all down into a handy little cheat sheet with the most important things to remember.
So let's run through it. Number 1, CAN's payload is tiny. Remember that. Number 2, ISO-TP fixes this by chopping up big messages. Number 3, it all works because of that handshake. First frame, flow control, and consecutive frames. 4, in Zephyr, you just need to remember 3 functions: bind, send, and reave. And finally, number 5, flow control is the secret sauce that lets the receiver control the pace and prevent data loss.
At the end of the day, this protocol just opens up a whole new universe of what's possible. You can now reliably push firmware updates, stream high-resolution sensor data, transfer huge log files, all over the simple, robust CAN bus that you already know. So the only real question left is, with this kind of power at your fingertips, what are you going to build?